Hello friends, welcome back to Online Math. We're going to be solving this simple exponential equation you are seeing right there on the screen. And so what we have here is 1 exponent x is equal to 2. So what is going to be the value of x that actually going to satisfy this simple equation? And so just make sure you follow through. I'm going to actually show you the trick to be able to find out the value of x that satisfy the equation. But just before we proceed, if you are new to our channel, do well to hit the like button, subscribe to our channel, and also turn on the notification icon so that whenever we release new content, you will actually get to know about it. And of course, if you are a returning subscriber, thank you so much. And you can also do well to hit the like button even as we proceed with this video. So I am actually going to start by writing solution. Okay, and of course the question we are solving is 1 power x is equal to 2. And so if you want to find out the real solution to this problem, one of the most basic things to do is actually to take the natural log of both sides. And of course, if I do that, I'm going to be having that I will take the natural log of 1 exponent x is equal to the natural log of 2. Okay, and of course the next thing I want to do is actually to utilize one of the properties of natural log, which basically say that when you have, let's say, natural log of a power b, you can actually bring down this b here so that this will change to b, and then multiply by the natural log of a. Okay, so I am actually going to utilize this to solve this, to simplify this further. And of course, if I do that, I am actually going to bring down this x here so that I have that this is x multiplied by the natural log of 1 is equal to the natural log of 2 right here. Okay, and of course the next thing we would want to do is actually to divide through by the coefficient of x, okay, which is actually the natural log of 1. And of course I can actually cancel this, and I'll be having that my x is equal to natural log of 2 and then divided by the natural log of 1. But this cannot be the solution to this, because when you actually check, this natural log of 1 is equal to 0. So we run into a problem. This cannot be the solution to this, and so we can conclude from here there's no real solution to this problem. So there's no real value of x that is actually going to satisfy this equation. But then we've got to also solve this equation. How are we going to solve it? So what we're going to do is actually to extend our solution to complex numbers. And of course, that is what we are going to be doing in the remaining part of the video. And so to do that, let's consider this beautiful polar exponential equation, which is exponential I theta. And of course, this is actually defined as cos theta. So this is cos theta. And then of course, plus I sine theta. Okay. So let's consider what the value of this is actually going to be for theta equal to 0. And so if we set our theta to be equal to 0, is actually going to change to, this is exponential I, and then multiply by our theta is 0 here, is equal to cos 0, and then of course plus I sine 0. Okay, and of course sine 0 here is equal to 0, and then 0 multiplied by I will give us 0, and cos 0 here will give us 1. So that obviously you are seeing that exponential I multiplied by 0 is equal to 1. Very good. And of course, let's also set our theta to be equal to, say, 2 pi. You also see that it's actually going to give us basically the same thing. So we having exponential I multiplied by 2 pi, okay, is equal to cos 2 pi, okay, and then plus I sine 2 pi. And of course, again, sine 2 pi is equal to 0, and then 0 multiplied by I gives us 0. and then cos 2 pi will be equal to 1. So obviously you will also see that exponential I multiplied by 2 pi, it's equal to 1. Okay, so of course you can actually continue to do this, and in general you're actually going to see that for theta equal to 2k pi, where k is just an element of integers, we are going to be seeing that exponential theta for values of theta 2k pi, it's actually going to be giving us equal to 1. So this is actually the general form of this. So for all integer multiples of a 2 pi, if when you take the exponent multiplied by I, it's actually going to be giving you equal to 1. And so in order for us to solve the problem right in front of us, we are actually going to be substituting exponential I multiplied by 2k pi for 1, and then from there we can proceed to solve. Okay, continue from here, we are actually going to be making this substitution. So our 1 here is exponential I multiplied by 2k pi, okay, and of course it's raised to power s is equal to 2. Okay, so we are also going to be repeating the same process we actually took here. Basically we are going to be taking the natural log of both sides, so we can say the natural log of the whole of this, so we have exponential I multiplied by 2k pi. Okay, and then of course let me put this in brackets to raise to power x, which is here, and then this is equal to the natural log of 2. Okay, so the next thing what we actually going to be doing is to simplify this stuff that we have right, and of course you will remember that exponential, let's say a multiplied by b, and then of course power c, you can also write this to be exponential a multiplied by b, and then of course multiplied by c. These are all the same thing, and then of course I'm going to use that to simplify what I have right here. And if I do that, this equation now changes to natural log of exponential I multiplied by 2k pi. Okay, and then of course multiply by x. Let me just put it right here. Okay, it's equal to the natural log of 2. Okay, so it's becoming cool. Next thing I want to do is also to utilize this stuff I had somewhere here. So this property that is here, so I'm going to be applying it over here. So if I do that, I am actually going to be bringing down the power, this power of exponent. So if I do that, I have that this is I multiplied by 2k pi x, and then natural log of e, okay, is equal to the natural log of 2. And of course you can remember that the natural log of a here is equal to 1. Okay, so if I use 1 to multiply these ones right here, I'm gonna be left with I multiplied by 2k pi x is equal to the natural log of 2. Okay, so the next thing I would do is actually to go ahead to divide through by the coefficient of x, so that I can actually get the value of x right here. So the coefficient here is I multiplied by 2 pi, of course 2k pi. Okay, then I'll also divide here, that is I multiplied by 2k pi. Okay, so these will cancel these ones, and then I'm left with x here to be equal to natural log of 2 divided by I multiplied by 2k pi. Okay, it's coming fine, but then we cannot leave this I here at the denominator, so we just find a way to bring it up to the numerator, and what we just do is just to multiply both the numerator by I, and then we also multiply the denominator by I. And if we do that, the numerator here now changes to I, Okay, so now changes to I, natural log of 2, and then divided by I times I here is minus 1. So I will also bring up this minus 1 right here. Let it be at the numerator, and then the rest at the denominator is now 2 k pi. Okay, so finally the value of x that actually satisfies the equation we are solving is x equal to negative I natural log of 2 divided by 2k pi. Okay, so this is the final answer, which of course satisfy the equation we are solving. And of course k cannot be equal to 0. K is not equal to 0. Okay, so this is very important. So thank you guys so much. Subscribe for more of our videos, and of course make sure you like this video. And of course, if you have any question, do drop in the comment box and I will surely get back to you. So I'm gonna be leaving it right here, and I'm gonna see you guys in my next video. Bye.